All right, let's finish up chapter 6 here. We're going to back up to 6-7, inverse relations and functions. Our essential question, what is the inverse of a relation? Okay, and by definition, you find the inverse by switching the x and y coordinate points. Okay, so if this was your relation, the set of 1, 2, 3, 4, 5, 6, those 3 points, the inverse would be just switch the x and the y. 2, 1, 4, 3, 6, 5. And if you looked at it graphically, and I pointed, here's the relation in green. There's 1, 2, 3, 4, 5, 6, and there's 2, 1, 4, 3, and 6, 5 in red. What you find is that if you took the line and I dashed it in blue here, y equals x, okay? What you find is when you find the inverse, you're taking and reflecting that over that line. So the inverse reflects over the line y equals x, okay? That's what it looks like graphically. Don't want to get into it real deep, but basically, you know, we've talked about reflecting over the x and reflecting over the y. Well, if you reflect over the x, y, you're just flipping everything over that way. And what you're actually doing is just switching the x and the y because y equals x. So you're taking y and making it x, okay, and vice versa, all the way through. What does that look like with an equation? How do you find the inverse of an equation? Okay, y equals 4 minus 3x. Well, you switch the x and the y coordinates. So switch the x and the y, so that's what I did. I made the xy and the yx. And then solve for y. Okay, so subtract the 4 over, divide out the negative 3, I get y equals negative 1/3 x plus 4/3. And that's the inverse of the equation. Okay, if I graph those two lines, I would see that they reflect over the y equals x. Okay. Not something we're going to do a whole lot of right here, but that's what it would look like. Alright, here, find the inverse with a quadratic. Okay, you got an x squared in there. So switch the x and the y. Don't make this x squared over here, just switch x and y, so now it's y squared. Okay, and then solve for y. Add the 5 over, square root both sides, you get y is plus or minus the square root of x plus 5. What you're going to find here when we start talking about functions, okay, straight lines are functions unless they're vertical, okay, which we don't see a whole lot. But when you're talking about quadratics, remember quadratic is u, opens up or down. And it's a function because vertical line test, we only hit the graph one time at each point. Well, when you take the inverse of a quadratic, the graph becomes a C going right or left. And when you go across there, you can see I hit it twice, here and here. So that's not going to be a function. The inverse of a quadratic won't be a function. So, if you look into the second part of 6-7, they start talking about the compositions. Okay, and we talked about compositions a little bit before. We kind of struggled through it a little bit, but what we're looking at here is if you have a function and its inverse, notice the inverse, we take it to the -1, kind of like looks like it's to the power. That's the inverse function. Just like that would be the function and that would be the inverse function. Then if you took the composition where you took f of x and you put it into x for f of -1, you would get x, and vice versa. If you took the inverse function and put it in for x into the function, you would get whatever x is. Okay? Well, what does that mean? Let's take a look at an example here. Let's say f of x is 6 over x minus 2. Well, the first thing you got to do is find the inverse of it. Okay? Switch the x and the y value, and that's what you get. And then solve for y. Multiply up here the y minus 2, divide out your x, add your 2 over, you get y equals 6 over x plus 2. That right there, that's our inverse function. Okay, that's f of -1. This would be our f of x right here. So what if x was 2? Okay, well if x is 2, what you should be able to do, and I'm going to use taking the inverse and putting it into the x of the function, okay, is this. If I plug in 2 into f of -1 and take that answer and plug it, because now that becomes the x in this function, then I should get 2 for an answer. Okay? Basically what it means is this. If I put 2 in for x here and solve this for y, and then take that answer and put it into that x, I should get 2 for an answer in this case, whatever the x is. Okay, if x was 5, I should get 5 at the end. Well, let's see if that works. So I take my inverse function, which is this, and I plug a 2 into the x. So I get 6 over 2 plus 2. Well, that's 3 plus 2, which is 5, so I get f of 5. Okay? So what I get inside is 5 for my inverse. Now I'm going to take that 5 and I'm going to put it into my function for x. So I put 5 in for x, I get 6 over 5 minus 2, which is 6 over 3, which is 2. It's the same 2 I started with. When that happens, then those two functions are inverses of each other. Okay? If I got any other number, then I'd say, oh, they're not inverses. Okay? So when I can take a number and plug it into the x for the inverse, take that answer and plug it into the x into the function I started with, if I get x back, what in this case 2, then the two are functions. They're inverses of each other. Okay, those two functions would be inverses. If I get any other number, then they're not inverses. Okay? A little confusing there. We'll look at a couple examples of that tomorrow, and then we'll wrap up the chapter and look forward to that Chapter 6 test. Okay, but we'll get into that tomorrow. All right, see you then. Have a good one. Bye.